Hello and welcome to the Spaces Virtual Conference on the theme of Net Zero Carbon, Climate Emergency 2021. My name is Greg Keening and I'm your chair for this webinar. Before commencing with my introduction of our speaker, I'd like to thank our 5 sponsors, Atkins, Faithful & Gould, IES, MPS Group and Willmott Dixon for their support. All the webinars over the 2-week period are being recorded and will be loaded to the Spaces YouTube channel. The recordings are only available to delegates and Spaces members, and a link will be sent at the end of this conference. If you have any questions during the presentation, please include them in the chat box, and we will try and answer them towards the end. Please do ask questions, as this will make the session more interactive and enjoyable for everyone. This morning's webinar is entitled Lifecycle of Net Zero Carbon Buildings, and will be presented by Alasdair Donn. Alasdair is Head of Performance Group Sustainability at Willmott Dixon, as well as a non-executive director of BISRIA, a member of their Soft Landings Technical Network, and is a member of CIBSE Homes for the Future Group. Alasdair will discuss the key steps to net zero carbon buildings and the importance of life cycle evaluation in carbon and cost terms, supported by case studies, examples from various Willmott Dixon projects. Alasdair, welcome. Thank you for supporting our conference, and we now look forward to your presentation.
Thanks, Greg. Good morning, everyone, and thanks for the opportunity to share a little bit of our experience of net zero carbon buildings with you this morning. I'm going to be talking about the life cycle of those buildings, and I'm just sharing with you examples of where each of the steps in the net zero carbon life cycle have been where we've sought to demonstrate and do evaluations and case studies on those steps in projects that we've delivered over the last few years in Willmott Dixon. So just to set the context a little bit, it's not a surprise to any of you, I'm sure, that the UK has a big net zero carbon challenge that the government has put into legislation that by 2050 us as UK PLC will achieve a net zero status across all the different sectors of our economy, and the construction sector in terms of both building operations and the energy that is associated with the buildings that we're all owning, constructing and managing is a big chunk of that pie, and also associated with that all of the materials and construction processes that go into creating those buildings in the first place. So those 2 chunks of that pie is what we're going to be drilling into today, to just break that down into pieces that we can see what the challenge is and try and come up with some solutions to address them. So in the context of that, that challenge is for us nationally, but all of the organisations here, some of whom are Spaces, members, and a few of them maybe in the future, I guess. All of your organisations, the organisations listed here, have declared climate emergencies and have set generally targets to address net zero carbon in their estate and their construction projects and their carbon footprint generally typically by 2030 or 2035. You know, a lot shorter timescale than the national picture, and that's excellent that those people have risen to that challenge. If you look at all of the people who've done those climate change declarations across the UK, you can see quite a densely populated map now. Intent is good. Everyone is stepping up to the plate to say, yeah, we want a net zero world, net zero buildings. So the big question really is, how do we do that? What are the mechanisms we can put in place to help us get to that point, particularly in terms of the built environment? It's net zero carbon buildings is really what we're focusing on, and the life cycle of those, to try and break that pie down into some manageable pieces. So luckily for us, some very clever people, certainly a lot cleverer than me, have come up with some excellent guidance and frameworks that can be applied to defining what a net zero carbon building is, setting standards for its performance, and giving a lot of supporting information in terms of tools and methods to use. Those documents from the UK Green Building Council, REBA, and LETI, the London Energy Transformation Initiative, are excellent guides to anyone who's starting on the net zero carbon buildings journey, and will be happily stealing lots of images from those documents as we go through the rest of the presentation. Here's the first one. This has got a nice graphic, just kind of showing in a relatively simple to understand way the elements that make up a net zero carbon building and its journey from start to finish. We'll look at all of those in some detail as we go through the presentation, but just to touch on them. So we're looking really at some of the things that we've been doing in construction for a long time now, but that we're setting explicit standards to achieve performance on. So reducing energy, so low energy use, supplying that energy from low carbon energy supplies, and in general that means getting rid of fossil fuels in terms of our energy sources. We've got potentially a balance issue between the amount of energy that we can supply and the amount we need to use. So we can consider how we might bring that in from other sources outside of the building or the development. We also need to think about the embodied impacts of the projects we're building, and we'll touch on that in a second. And finally, with all of that lot, once we built it, designed it, constructed it, and provided its energy, we need to measure and verify that it is actually net zero carbon in operation. Because if it isn't, all we've done is create lots of paperwork that says this is a net zero carbon building, everyone's happy, nice tick. But if it isn't actually net zero carbon in operation, we haven't done anything to help the planet, and that's why we're doing this in the first place. So it has a little extra anti the net zero carbon building that, this time round in construction, we actually need to deliver the actual performance that we claim at the outset or that we're aiming for. So looking at the life cycle of a construction project from start to finish, a number of you may have seen these kind of diagrams, but this is from Letty's document, and it's quite a nice way to explain it. So it goes from A to D, which is a nice simple methodology. The A stage is all of the material manufacturing, transportation and construction processes that go to create the building. So practical completion is the end of the A stage. And that's, that has a certain amount of carbon associated with it, of course. The B stage is its life cycle of operation. So that's all of the energy it uses, and also all of the maintenance and replacement that will happen over the life cycle of that building. For instance, M&E assets that have a short replacement life cycle are going to have a higher embodied impact in carbon terms because they're going to be replaced more often. So it's no good being efficient if it doesn't last long. And finally, the C and D stages, which are sort of end of life, reuse, deconstruction and disposal. So we're going to focus really on the A and B stages today as we go through the presentation. So if you translate that life cycle graph into diagram rather, into a graph of how much carbon is actually created in those A and B and C stages of the construction process, you've got a nice big chunk at the beginning associated with the whole A stage of creating the building up to practical completion. You've got energy consumption and carbon associated with that energy as the building is used. And those little red blobs indicating where bits of kit are replaced or maintained through the 60-year life of the building. And then another chunk at the end, the C and D stages, where at the end of life stuff is accounted for. So those bars are kind of arbitrary in size, but it's fair to say that if you looked at the whole life cycle emissions of any building that we create these days, because the energy efficiency of our buildings is generally pretty good now. It needs to get a little bit better, but it's already reasonably good. The sum of all the orange bits is actually still, is of the same order of magnitude potentially, or maybe slightly smaller than the embodied impacts. So we really do need to think about both of those aspects when we're looking at a net zero project. So to just getting a little bit of noise in the background there if someone's not on mute, thanks. So just to balance to show what the net zero actually means. So what's this net zero part of the story? So it's about a balance really. So net zero operational carbon as defined in a building means that all of the orange bits in that graph add up to a balanced amount of renewable energy and offsets in carbon terms. So that in net zero, in operational terms, which is all the operational carbon in the life cycle of the building, that's balanced by an equal amount of renewable energy and offsets. And then if we look at the whole life carbon in net zero terms, that also means that you have to consider all the red stuff, all of the embodied impacts, particularly in the A and B stages, to create a net zero building. So that's a bigger ask, quite substantially different task to make it net zero in whole life terms. So both of those options are possible in terms of how we'd set out to do a project today. And I'll focus on each of those aspects as we go through. But I think that definition, what you're aiming for in net zero terms, is a really good place to start in any given project that you're involved in. Because unless the goal is clear at the beginning, it's going to be difficult to get there. So let's look at some of the steps in that process. If you remember back to that Letty diagram. So the first of those steps, and perhaps the most important one in a net zero carbon building, is to make it as low energy use as is realistically possible. And that means reducing energy consumption by building fabric improvements and highly efficient building services, essentially. Not considering anything to do with renewable energy. So we'll come back to that in step 3. Step 2 is having reduced that energy demand of the building and made it as efficient as we can. We also do as much as we can in the design and procurement stage to reduce the embodied carbon of the building. Assess and reduce is the key message there, and we'll come back to that later. The third step is having reduced that energy demand, we then have to provide an equal amount, ideally, of low energy carbon supply to make that net zero balance. And we try and do that from as much on-site generation as we can. And if we can't generate it on-site, then it needs to be provided by grid sources off-site or by carbon offsets as a last resort. And the last step in the journey, measurement and verification. So we need to actually measure that both the energy demand and the energy supply are in fact balanced, and a net zero carbon building is actually happening in the course of its life cycle. So that performance measurement piece is much more important for a net zero carbon building. So coming back to step 1, let's look at a little bit about how we can do that. So the first question that you've probably all been asking already is, how low do we need to go? As someone once said in a film. And that shows really for some typical buildings sectors where those buildings currently are in terms of the size of those blue bars. And that's showing a measurement called energy use intensity, which can become a lot more common in construction in the future. It's not particularly familiar to everyone at the moment, but essentially it's how much energy translated into electrical energy terms, because we'll see electrical energy is key here, is used per square metre of GIFA of the building per year. And for a typical office building in the UK of any age and size, that typical number is about 145. For a net zero office, we need to get that down to about 55. And you can see the other translated elements for schools. So that's a defined standard within those framework documents by UK Green Building Council and Letty that you saw earlier. And that sets the right level of energy achievement for a new build construction of that type of typology. Obviously, it will vary a little bit by type of building and use. One particular solution that is getting a lot of attention these days, that you'll see some examples from in a minute, is the use of the Passive House standard. And in energy efficiency terms, that's roughly where Passive House sits. It's sitting sort of at or in some cases better than the targets for net zero buildings that are commonly accepted as appropriate in the UK now. So if you build to Passive House standards, you will hit the energy use step 1 target. That's not essential, but it's well worth considering, I think, as an option, because it has some other benefits also. And I'm just going to take you through a few case studies of buildings that we've built that use the Passive House standard. Just to say what it is, number 1, it's what I just said, the best in class, really, energy demand reduction approach for buildings, particularly in terms of space heating and also total energy consumption. But not just that, it focuses equally importantly on an excellent internal environment, particularly in terms of air quality, of fresh air change rates, and general air quality to the space, and also to the thermal comfort of the building in overheating mitigation and prevention in summer, and considers future climate conditions as well. So it's a pretty holistic way of achieving high-performing buildings. It's achieved by all of those things related to fabric improvements, highly efficient services, and also a very robustly and externally certified quality standard. So it's a decent approach. We've constructed 3 large passive house projects that you see in the top there, a couple of schools and a large university building, all of which have met the passive house standard, and we've been doing some performance monitoring on those as well to ensure the performance is in line with the passive house expectations. And we have a number of other projects currently in pre-construction in residential, higher education, and a couple of other schools projects. So I'd say if any of you are looking at passive house as a potential route to net zero, it's well worth weighing up the pros and cons of that approach, and a number of local authorities are already well down that journey. Just a little bit of case study information on the first of our projects in the University of Leicester, just to give you a feel for what a passive house building looks like. Large university teaching building, about 11,000 square meters. Internally, the usual kind of standards of quality and space definition architecturally you expect from a flagship higher education building. Plenty of use of natural daylight and everything in the normal way that you'd expect. But essentially, in passive house terms, just a highly energy efficient building fabric with very high levels of insulation and mechanical ventilation with heat recovery throughout the building. You can see there some of the features of the building, a little bit of a, one might say, excess of sustainable features in that project. And that's some of the learning that we've taken to future projects, actually, is that some of those renewable energy technologies were successful, some weren't. And I'll try and touch on some of those as we go through. Gives you a feel for the nature of the building. And a little bit now about some of the processes involved in delivering passive house in a construction project. This is actually the second project that we delivered, large secondary school in Lindborough of Sutton with cross-laminated timber construction. And you can see there another secondary school building, nice internal environments, nice use of natural materials and concrete and timber and so on. But passive house can be built from anything. It doesn't set a standard in terms of materials or construction methodology. It's really setting a standard for energy performance and internal environment, and that's the key focus it has, really. So in building a passive house, substantial focus on detailing and air tightness of the building. So high air tightness and lack of energy performance loss from passive permeability of warm air is something passive house focuses on. And we've done a lot of work to involve our supply chain partners in getting to that level of quality that's needs to be achieved. You see there's some mock-ups and training sessions that we've been running for our passive house supply chain partners on those projects. Very simple, kind of focuses on basic build quality of highly performing insulation with really excellent installation quality, all verified by external certification. And we also combined on this project a fair bit of prefabrication and NMC type approaches. There you can see an on-site flying factory for construction of timber frame elements of the walls, and CLT structure used for the sports hall to make a rapid build system, and also one that's very well adapted for good air tightness performance. In a passive house building, and any building that's achieving high levels of air tightness, sequencing and testing of air tightness at different stages of the build is important. So you can see there's a small section of the school in Sutton where we've done a full completion on that one section to test the air tightness strategy of the envelope and all the sealing around the window and the internals. And that's very valuable approach in achieving high performance in air tightness terms. We had a member of our site team who was the Passive House police in terms of our supply chain and attention to detail on not making perforations in the air tightness barrier. Simple stuff, but a rigorous process. And we also integrated Passive House with our site quality management approach, and that's using a software capture device called Field View, where you see the site manager there using a tablet to take photos and capture quality information as he's going around the build. And in terms of learning, perhaps a demonstration between our first project here on the left and our second large project of how difficult or easy it was to achieve the air tightness target. We actually had a number of attempts with successive improvements in changes, modifications to get to the challenging target on project 1. We achieved a more challenging target with the first attempt on project 2. So at least in that respect, I think we've got some good learning there that we've shown that we've transferred from one project to the next. This project is our third Passive House building, and an interesting one because it achieves a standard known as Passive House Plus. That's actually the normal Passive House standard plus additional renewable energy generation, and you'll see that on the next slide. Just some internals there of the school building, primary school building. Fairly typical classroom, supplying extract ventilation at the back here with normal opening windows, doors to the outside. So, in functional terms, same as a lot of other primary schools you'll be familiar with. And here you see renewable energy side of things. So in terms of Passive House Plus, the energy demand in annual terms for the building is exceeded by the building's annual generation. And that makes it a better than net zero building in carbon terms, which is a side benefit of the Passive House Plus standard, if that's something that is focused on for the project. So step 2, we've reduced our energy as much as we can through Passive House or other similar approaches. What do we do about that embodied carbon, all of that stuff that we've used to create the building in the first place? So we're talking about the red bits in this graph, essentially this big one at the beginning, but also some aspects of how the equipment is being replaced and maintained as we go through the life cycle of the building. And this graph is taken from Letty's Embodied Carbon Primer, which I'd say is a publication that I myself spent some time reading. I'll put my hands up here. I'm an energy performance guy. Embodied carbon is something that's new to me, and it's I've taken myself down that journey on using some of the materials that Letty have developed, which are excellent. The guide sets various standards and achievement levels for different building typologies in terms of best practice, and it shows how the different elements of any typical building are built up. And the overall message in embodied carbon is look at the big stuff, big, large, massive, heavy things on big items on the bill of quants in volume or mass terms are the things that generally are the big ticket items in embodied carbon terms. You see here an example of Letty's approach. They've done evaluations, apologies for the figures, but that figure there says 800 kilograms of carbon per square meter of build area per project. So that's a metric that you can assess against in terms of calculations and demonstrate that at design stage or construction stage, you've achieved that target. So it's eminently measurable, and there are some excellent tools that exist to do that with. We're using a tool called Ecolab, which you see some visualizations of here, which essentially allows you to optioneer. You see some comparisons here between traditional construction and CLT timber frame option. So the software takes inputs from BIM models, evaluates embodied impacts of all of the parts of the construction process, and allows you, for instance, to trade off or evaluate options around structural frame, foundations, envelope, and all of those things which are evolved in the early stages of design and can make substantial difference to different embodied impacts for projects. So the big message here with embodied carbon is, because it's a completely new thing to construction for us, the big message is measure it. Put some tools in place, at least on your projects, to measure what the embodied carbon of the projects you're delivering is. That's an excellent starting point. And then we can start to look at ways in which we can reduce and improve embodied carbon. So step number 3 in the journey is to consider the energy supply to the building. We're used to thinking of renewable energy as some kind of abstract thing, but in a net zero building, that energy, and we're talking electrical energy here, because just to reiterate this point, all of the guidance for net zero carbon buildings for new build construction is that gas is out, as is any other form of fossil fuel. Whilst it's still within building regs to build with gas heating and hot water systems, if you're building a net zero building, don't, is the message. And that has implications, clearly, but that's technology-wise is eminently achievable with heat pump systems and other solutions. And the challenge is because if we don't reduce direct fossil fuel use in buildings, we are building in carbon consumption that is going to be there for a long time to come, and we'll perhaps have a little debate about that later when we have a chance to chat. So with low carbon energy supply, this type of system that we found is really far and above the most efficient and effective way to do that is with solar PV generation. Just to show some examples of how we've used that on projects. This is a building at the University of Warwick that we completed last year. And you can see there are normal PV systems on the flat roof, and also the use of PV as a vertical panel, replacing metal elements, forming a large plant screen around roof-mounted plant equipment. That's actually on all 4 faces of the building, and is operating at a slightly lower efficiency level than the PV on the roof, but nevertheless an efficiency level that's actually pretty decent and contributing a substantial amount of energy towards the building. Beyond the scale of buildings that we are constructing, this is actually one of the largest rooftop solar PV installations in a building in Europe, in Holland. It's a substantial size system, generating roughly 20 or 30 times the energy that the previous building showing. And at larger scale still, this is the largest solar farm in terms of grid generation of solar energy to the UK in Kent. When it's finished, it will generate 350 megawatts of energy. Hinkley Point is something around 2,500 megawatts. So gives you an idea that these things are getting up to the scale of power stations, and that renewable energy in the grid, and the fact that the grid is rapidly decarbonising because of that energy, together with that from wind farms, is the reason that electricity is the only show in town for buildings in the time frame of the next 10 to 20 years. So that's why we're focusing strongly on electrical generation here. So all very well, but how does it work? Back in the 20s, we did, when we were starting to install PV quite regularly on projects, we did a bunch of performance monitoring studies on a few key buildings, looking at what our design expectations were for solar energy and how they actually performed. And in every single case, we've got performance that is in line with expectations, taking into account normal annual variations in weather patterns. And PV is really a technology that performs. That solar farm that you just saw is based on the fact that every unit of energy that generates has value, and that value is what pays the money to invest several tens of millions of pounds to create it in the first place. And if it didn't perform, it wouldn't be there. So it's as simple as that, really. It's good technology. It needs monitoring and all of the usual other things that make it operate successfully. But it's good technology, and it's also getting cheaper. This is the capital cost variation that we've seen in the last 8 to 10 years on a system which is generating 200 kilowatts of electrical power on a building in Worthy Farm in Glastonbury, actually, not one that's been used much in the last couple of years, but hopefully will be soon. 200 kilowatt system, you can see there what the difference in capital cost has been due to economies of scale in manufacturing production associated with those very large grid scale plants that you saw earlier. And we in the built environment industry can profit from that, so that's to our advantage. So it's a more affordable technology. It's an effective technology, but it still has a cost, and it's still something that we're not used to installing in large quantities on buildings. So we've come up with a solution in Willmott Dixon to give our customers an alternative approach to, rather than purchasing the PV generation equipment, to purchase the power from that equipment by partnering with community energy groups to have them install and operate PV systems on our buildings and provide energy to the customer in that methodology. And that's something that we're seeking to roll out on some projects quite soon. You see a couple of them here that are in design stage at the moment. A large school building in Wiltshire, which is aiming for net zero carbon in operation. So the generation from that rooftop is sufficient to provide all of the energy needs for the school building, two-storey school building that it's attached to. And a project here in Bristol where we're doing a refurbishment of a Grade 2 listed building, and subject to planning permission, we're hoping to install a large system on the pitched roof of the building, which used to be called the Colston Hall, now called Bristol Beacon in the centre of Bristol, that we're constructing a major refurbishment on at the moment. So PV is applicable to most situations, and something we're going to be looking at a lot more, I think, in the future. So the last step of our journey, the most important one, as I said, and it's the reason why my title is Head of Building Performance at Willmott Dixon, that I'm measured by how well our buildings perform, and to measure that we need to actually put some kit in place to do it. So let's look a little bit about how we've done that on some projects. I guess just to reiterate that issue around performance, in construction, we've traditionally been judged on those top 3 metrics, CTQ. I don't think I need to tell anyone what those refer to: cost, time, and quality. And performance has taken a little bit of a backseat. In the net zero world, performance is key, because unless we achieve that, we're not really doing anything. And if we do, as a construction industry, that has benefits as operating cost savings and carbon emissions reductions, clearly, but it also has benefits for us as the delivery part of the business. It's good to measure how the stuff we build performs. It helps us improve product quality, potentially helps us optimize the supply of M&E equipment and capital cost, not oversizing systems, for instance, and maybe for those that are involved in that in a net zero world, it's giving them more of a competitive edge than they would have in the past when it was less importantly focused on. So coming back to Passive House, how does that perform? We said that we built these buildings. How did they actually work out? This is the first one where University of Leicester project, where we're measuring there using a precursor to what you'll see later we developed as a standard process for our business to measure actual energy performance on the left against the target energy performance in any given month. So we're looking at that as a process to manage and track energy performance. And for that particular building, we had an objective to achieve a display energy certificate rating of A, which is less than 25, meaning it's got less than 25% of the carbon emissions of a typical building in its type. And we achieved that a couple of years after the building was handed over. On this project, you can see there a fairly graphic illustration of how the Passive House building performs in energy per square metre terms. And energy cost associated compared to the previous building on the campus across the road, which was built in the 60s. And that really illustrates the benefits that a Passive House net zero building could give you. It's not only is it a great building and a great environment to teach and learn in, which it clearly is, but it's a massive saving in carbon and energy terms and cost terms for University of Leicester. Moving on to the schools projects, you'll see there are some comparisons of the Harris Academy Sutton project of space heating performance. You see variation over the seasons there, which you would expect for space heating, of course, and a comparison of the average actual performance of value of 24 versus the design target of around 27. And in electricity terms, performance in actual terms here, which is substantially below the target value, and that's related essentially to the school being partially occupied and ramping up in its occupation levels. So you would expect that because of the nature of the way it's occupied. On the Passive House Plus school, you see also there some, again, the similar variation in heating performance over the season, and a comparison of the target value of 11.5 with achievement value of around 11 that we've measured so far up to the spring. And we're learning some lessons there around performance management. We detected some issues with the PV system, for instance, that were detected because we were monitoring it. Some rectification of defect issues there, and optimization of the ventilation system and other parts of the heating system to get the best performance in use. So even a passive house building has things that go wrong, and even a passive house building needs monitoring and optimizing, and that's the case in any project, and one that's a good lesson to learn. If you'd like to hear about the customer's view of a passive house school building, I'd encourage you to have a look afterwards at this link. I think Fiona might be kind enough to circulate this link in the post materials, with James Fisher talking about what it's like to teach kids in a passive house school, and the education benefits that might bring, as well as the environmental benefits. So from those measurement and verification sort of pilots that we were doing, we developed a process that we're now doing as a standard delivery item on a number of our projects called Energy Synergy. And in simple terms, that's doing the basic measurement and verification piece. It's creating an energy performance plan for each of the buildings that we're creating. And that's developed from the M&E services and building design information, together with how our customer is equipping and operating the building, to create a holistic energy performance plan that we then measure against. And that's essentially what we did on the University of Leicester building, and that's what we're doing now in a number of our other projects. You see there a process information that talks about how we take our customers through that process map on each project. One particular case study here is the University of Warwick, so a large sports centre that we completed a couple of years ago now, built to good energy performance standards, but not a net zero building as such. Nevertheless, one where this performance monitoring approach is very useful. You can see there comparisons of target versus actual performance in terms of various chunks of the energy pie. And the graph here, which highlights performance in one particular part of the gym equipment. It's one of the largest gyms in any building that we've built so far that exists on the sports centre there. And it has this shows a daily graph of midnight to midnight in energy consumption terms. You can see the peak of use during the day, but also a substantial base load that runs all the way through the night. And that's really because of some issues around switch off of standby mode in various bits of gym equipment, and some learning there that unless you procure the right equipment and consider its holistic energy use, that can create some quite substantial issues. So we're able to identify that and provide some solutions for that. And you can see here some idea of the savings and improvements identified through using energy synergy on this building in Warwick, and the financial value and carbon value associated with those savings. And if you look at our website, you can see Joel Cardinal from the university sustainability team talking about the benefits of that process and how they've used it on subsequent projects to help them manage energy and carbon performance. You'll see here another example of more straightforward, simple things on a school project that we used it on in Wales, where we had a hot water generation system that had a BMS control error that meant it was running overnight 24/7 when it didn't need to run in normal times. And that simple controls rectification made quite substantial percentage and some reasonable financial savings for the school in terms of how it operated. Simple things, but still tangible savings. So I appreciate that we have rather cantered through the journey of net zero carbon buildings. We've got 15 or 20 minutes now to answer any questions that you might have, and I'd be really happy to bring Greg back in now, and we can look at some of those, and I'll do my best to answer them.
Thank you ever so much, Alasdair. You absolutely raced through that. There's loads of information there. I think there's several sessions in that 1 to 40 minutes that you presented. So thank you ever so much What it has done is generated a lot of questions, so which is really good news, because people obviously got things they want to understand. I'm going to start probably the order they came in, and we've got one from Rachel, which is, does Passive House take into account embodied carbon in building materials and environmental impact of materials?
That's a good question. Strictly speaking, in the Passive House standard, it doesn't take account of embodied carbon, no. So, so Passive House does focus very strongly on the energy steps one in that journey, and step 3, which are energy performance reduction and supply of renewable energy to some extent. So embodied impacts are recognised now as being equally important in that life cycle, and therefore in a best practice project aiming for net zero, for instance, if it was a Passive House project, it would also be beneficial to have an embodied carbon evaluation process and targeting along the lines that I explained in parallel with that Passive House approach. So no, that is one gap in the Passive House standard currently. It might be one that's filled in the future, but currently it does everything else, but not that. Yeah.
Okay, and kind of connected in that with embodied energy and importance of that, we've got questions come in, is we currently design for 50-year building life, and it's very large quantity of carbon is produced as its construction and demolition. Is there not a strong argument for building for a longer life to lengthen the construction and demolition cycle?
Yes, I think there is, and that the length of the life cycle that you consider for an embodied carbon evaluation is to some extent defined by the nature of the project and what kind of asset it is and so on. But yeah, I mean, building for the long term, maybe putting in something that has higher cost and better longevity and lower embodied impact during its use cycle and its end of life stage is is something that those evaluation tools allow you to do. We don't have the tools to do those evaluations before, but if we start using them, then we can start to offer customers, or consider, if we are customers, those options that we're presented with to look at the differences in embodied impacts and operational impacts. And there will be trade-offs. There will be solutions that are very energy efficient but have high embodied impacts. That does exist. A lot of high performance insulation products are relatively high embodied impact, but those trade-offs and benefits, unless we start measuring those things, we can't really improve. So that's the message, really.
Okay, there's a question here which is around energy use, and whilst it's important to have stringent energy use in new builds, surely the main issue is ensuring similar approaches in all existing buildings.
I completely agree. I haven't focused on the existing building sector today because our main focus in Willmott Dixon is in new build and major refurbishments to existing buildings. But the refurbishment part of that piece is important. Any refurbishment rather than new build inherently has some huge embodied carbon savings, because you're typically saving structure, foundations, maybe some other things, and therefore those kind of rebuild versus refurb decisions, I think, are going to be viewed quite differently in the future. And there's no reason why, a refurbishment can't be as energy efficient as a new build. For instance, the Passive House standard has a very good refurbishment standard called NFIT, which it aims for in buildings that have been refurbished. A major refurb is no different to a new build, really, and it should, the performance levels can be equivalent. So I think those are going to be happening a lot more often in various contexts.
Thank you. Thanks for that. I think the cat has woken up. I can hear some meowing.
Yeah, the cat's here. Yeah, so we've got traditional noises off.
Definitely, as soon as you go live, the cat will wake up.
It's shut outside the door.
Just as a general point for everybody, Dr. Joe Jack Williams is presenting for Film Craig Bradley Studios on his embodied carbon next Thursday at 9 o'clock. That's a free tool that they've developed at FCBS, and it's really interesting, and he will run through how you can apply that. So that's next Thursday for people who are kind of raising questions around embodied carbon. Next one is around Passive House Plus, measured on a yearly basis. Is it? If so, is it likely to omit the importance of season demands in UK winter versus summer, especially if solar PV is the only renewable energy utilised?
Yes, that's a very good question, and it touches on a future issue or even a current issue that we're going to have to start thinking about. To answer your question, Pacifies Plus does consider the energy demand on an annual basis. Yeah, so net zero, and that's also common with other net zero definitions currently. All of the UKGBC, REBA, and equivalent Pacifies standards are based on annual consumption and annual generation. And you've accurately identified the issue that if you look at it in a seasonal basis, in summer, that building will be consuming energy in net terms. There's no doubt about that. In winter, beg your pardon. So it's going to be using more in winter, using less in summer, generating more in summer, generating less in winter if it's solar generated. So those are out of sync. And therefore, the time value of carbon on a seasonal and on a daily basis as well, because carbon is more available in daylight hours and in windy days than it is in other times. So that time value of carbon is something that I think will become more and more important. There's a paper which I'll maybe circulate a link to afterwards that we collaborated on with WSP to look at that issue actually, and therefore raise the importance of things like energy storage in buildings. So if you had PV generation coupled with storage, for instance, that addresses a lot of the daily variation in carbon factors. It doesn't address seasonal variation. That really is a big challenge. And that's for us as a nation in the grid to sort out really. In building terms, we can't help it that buildings need more energy in winter than summer for heating, typically, unless it's a cooling cycle. But so we can mitigate that by reducing this demand, but the issue remains. Yeah, so good point.
Okay, it's a couple of interesting ones now. In terms of costs of site quality, would you say that once the site team are trained and have built a couple or so buildings, that the workmanship required still attracts a cost premium? And does the way of working become the norm that is applied on all future, whether passive has certified or not?
Yeah, I'd say particularly where Pacifies is there, it's we found that just in general quality terms, even outside of the things that are related to energy performance, which Pacifies is focusing on, it's a great discipline because it kind of gets that ethos of building to a specific design standard with architect's details that are actually built to, not just indicative, that are that where quality is monitored and measured externally, and therefore that's a good philosophy, and it has, I think, translated across some of the teams that have moved from one Pacifies project to other projects. So I'd say it's a good ethos, and we've certainly seen some good practice improvements approaches across the business because of it. Just from a psychological standpoint for people, and people like to build high quality buildings, and they like to be recognised for building high quality buildings. That's it's human nature, and that's if that can be recognised by the way the project's structured as well, that's a great thing, I think.
Okay, Robert's asked a question here. What is the financial payback period of the flat roof mounted versus wall mounted PV panel array on top of Warwick University building?
Okay, I could probably follow up with a few specific details on the numbers on that, but just to give you an idea, the efficiency level of the vertical panels in overall terms compared to the horizontal ones is about 75 to 80% as efficient. So yeah, you're losing maybe a quarter in efficiency terms, but you're also gaining in aggregate terms substantially more energy. So the efficiency, because panels are inherently more efficient and more cost effective, the cost of energy from those vertical panels is substantially less than it's been from historic PV systems that have been optimized for flat roofs. So it's the combination of those two factors is making it a more significant contributor to future energy needs, I think. So I'd encourage people to think about those things if they've got projects that work for that.
Okay, Philip's asked the question is, why is low carbon energy supply only at step 3? Surely it's the single clearest positive thing to get on existing buildings ahead of actually getting them better insulated.
Well, that's an interesting question, Philip. So I think what Philip's saying is why not just take the building that you've got in energy efficiency terms and use up all its energy, provide enough PV or other energy sources to meet that demand. That would be net zero. Well, it would be in technical terms, but what it would also be is it would be using quite a lot of renewable energy. And unfortunately, in UK PLC terms, we are short of renewable energy. As more and more of our existing economy in terms of buildings and other things, electric vehicles, et cetera, all go away from gas and fossil fuels towards electricity, we need to make sure that our buildings reduce the demand first. And that's why it's step one, because unless we reduce the demand, both in embodied and in energy terms, then we're not really delivering the right kind of net zero building. We're just using renewable energy to solve the problem where we really need to be reducing demand as well. And that's why that demand reduction is step one, and it will always remain that way in the process. It's always a question of how far you can get, how low is realistic, and that's going to vary from project to project. But just sticking renewables on is not really a long-term solution for us as a business, as a country, really. Yeah. Be great to be able to have an actual discussion.
Okay, thank you. Next question is from Steve.
Sorry.
Yeah, it's. I mean, I think what it has done is we will take some areas from here and actually do future webinars on some of these subjects in a bit more detail. So, Steve Owens has asked, if a new build reaches the BREEAM excellent standard, how does that compare to net zero carbon projects that you have undertaken, not passive house?
Okay, so good question. So BREEAM is obviously a very well-known and understood energy, sort of sustainability certification process, including energy and carbon performance. And it has extended in recent iterations of BREEAM to include, measures of actual performance as well as design performance. There's no direct link between highly scoring BREEAM building and a net zero carbon building, but in general terms, a BREEAM excellent building will generally achieve quite high levels of energy efficiency. It's just that it's not explicitly targeting that kilowatt hours per square meter value that a net zero building would. So it's a focus away from compliance methodologies based on EPC values and things towards energy targets that are about energy, not about carbon as such, and also that they're levels that are measurable and verifiable. So that's the key difference, really. But yeah, BREEAM is good. It's just maybe not quite sufficient in the current context.
Richard's asked the shortest question, but a really interesting one: is passive house the only realistic show in town?
No, it's not. And we are not going to be building every single new build construction in the UK to passive house standards, but it is a good standard, and it's appropriate for lots of buildings, and has some additional benefits as well for for customers and for other things. It's a good place to go in terms of considering options for any net zero building, but in principle, if you follow the framework approach of UKGBC or others to demonstrate through detailed calculations in design and verification that you're achieving an energy performance standard, that you're maximizing renewable generation, and you're considering embodied impacts and all of that stuff, and you've got a way of measuring and verifying it, then those are sufficient, and you don't have to do passive house to get to that point. But passive house does quite a lot of the journey for you. So, and it has some additional benefits. So,
Robert's asked, is CLT the lowest embodied carbon building material? How does it compare costs to other materials? And I will also join in other cost webinars he's put, because Fiona's been advertising at the same time. We've got other cost webinars coming up.
Okay.
So is CLT the lowest?
Yeah, what about CLT? I'm probably not the expert on CLT, but I'll give you my view on it. I mean, it's an excellent and very flexible construction technique. It does tend to have lower embodied impacts than some alternatives, but it depends what the alternative is. It's probably not substantially different from steel frame system with a lightweight envelope, for instance, but it probably is substantially lower than an in situ concrete frame or sort of heavy masonry facade. So it depends a lot on the structure of the massing of the building and what the alternatives are, but it does have some combinations of embodied carbon attractiveness, if you like, and also buildability and good airtightness performance in terms of being a large elemental construction, inherently easy to detail in that way. In cost terms, again, it's a comparative issue. It probably isn't the cheapest solution per cube of square meter of materials, but in overall program and project cost terms, it can be, and that's why we've looked at it on a number of buildings, and it has some quite attractive features around getting rid of internal finishes and that kind of thing. It's probably fair to say also that being timber construction and in the current building regs environment and post Grenfell, those will always have extra focuses to assure them. So, we won't build in CLT and timber in certain building typologies and heights in residential scenarios, for instance, in Willmott Dixon. But we are considering it as options on lower story non-domestic projects. So it's it's got lots of issues to consider on that.
Thank you so much, Alasdair. I think I'm going to have to call it to an end now. So thank you very much for your time today. I'd also like to take the opportunity, our sponsors, Atkins, Faithful and Gould, IES, MPS Group and Willmott Dixon. Thank you to all the delegates for attending. What I would ask is please could you just take a few seconds and answer the feedback question on the screen. On a scale of 1 being poor and 5 being excellent, how would you rate this webinar? And this is really important for Alasdair because as he stressed earlier, he's really keen on measurement and verification. So this point is we've been doing on everybody, and it's useful for us as we go forward. So if you could just answer that simple question, thank you. A reminder that all the webinars over the 2-week period have been recorded and will be loaded to the Spaces YouTube channel. Delegates and Spaces members will be sent a link at the end of the conference, and the recordings are only available to Spaces members and delegates. Please circulate details of this conference to your friends, colleagues, LinkedIn, etc., as we are having webinars every day now until Friday, the 18th of June. Thank you ever so much for joining us today, and enjoy the rest of your day.
Thanks. Goodbye.
Bye.